Okay, and lastly, if we look at question 4, a manufacturer supplies MP3 players to retailers in batches of 20, which are randomly selected. Long-term analysis shows that 5% of the players are faulty, and it asks us to write down a suitable model for the distribution of the number of faulty MP3 players in a batch, giving the value of any parameters. Right, luckily for you, the only distribution that you know at the moment is the binomial, so it has to be a binomial, but soon you will know the normal distribution, so we need to think about what makes this binomial and not normal. So the things that make it binomial are there are a fixed number of trials, it's a batches of 20, so it's a fixed number of trials, the probability of so there's failure or success, the MP3 player works or it's faulty, there aren't any grey areas. The probability of success is constant, so the probability that it works is 95% or 0.95, so that doesn't change. So that's how, if you did know the normal, you could still choose that this would be binomial because it meets the conditions for a binomial. So we need to say, because we're going to define our variable, so I'm going to say let x, you see that? Let x be the number of faulty MP3 players. Okay, so you cannot state the distribution of x until you've defined x. So let x be the number of faulty MP3 players. X is distributed binomially, and then remember we've got NP, where n is the number of trials and p is the probability of, p is probability. So we've got 20 in our batch. The probability that it's faulty is 5%, so 0.05. So what I've done there is I've defined x, I've stated a suitable model because I've said it's binomial, and I've given the values of any parameters, which are 20 and 0.05, which gets you the 2 marks. For part B, it says find the probability that a batch contains no faulty MP3 players. So I want the probability that x is 0. There are no faulty ones. You can put it into your calculator, but I would encourage you, this is a 2-mark question, I would encourage you to write down some working. So we know that out of 20 of the MP3 players, we want none to be faulty. 0.05 is the faulty ones. I want none of them. So if 0.05 is faulty, 0.95 is not faulty, and I need 20 of those. And if you put that into your calculator, I don't know what you'll get. Hang on, let me work it out. You'll get 0.358 to 3 significant figures. Okay, you can get this straight from your calculator by using the binomial function on your calculator, but this is a 2-mark question, so I'd really like you to show me something that's going to get you a method mark as well as just put down the answer. Okay, so there is your method, there is your answer. And then part C says show that the probability of there being more than 4 faulty MP3 players. So I want the probability that x is greater than 4. So if it's more than 4, it could be 5 or 6 or 7 or 8 or 9 or 10, blah, 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 all the way up to 20. You can either work those out individually, which we don't really want to do, or you can turn it into a less than or equal to and then use the cumulative distribution function on your calculator. So if it can be greater than 4, let me slide this along a bit. Okay, so here's my numbers here. They carry on in both directions. Well, stop at 0. They carry on and it carries on up. So I want the probability that it's greater than 4. So I want this bit here, which means it's all of the probabilities. All probabilities add up to 1. Take away this bit here. And the bit I want to get rid of is the probability that it's less than or equal to 4. Okay, this you can do on your calculator. You could work out probability of 0, probability of 1, probability of 2, probability of 3, probability of 4, but again, that's still quite a lot of working, so you can just use your calculator. So we want menu. What have I done here? We want number 7, I think, is it 7? Yeah, number 7, we want to arrow down because we want the binomial commutative distribution. So arrow down to see binomial CD. We just want a variable. So x for this question is 4. N is 20. P is 0.05. And then you get your answer, 0.9974. So the probability that it's less than or equal to 4 is 0.9974. If we do 1 minus that, we get 0.0026, which is actually what the question is asking for. Okay, so there's your working and there's your answer.